The product of the readings of an AC voltmeter and AC ammeter is called apparent power. What is the basic unit of electrical power? Watt. What is the term used to express the amount of electrical energy stored in an electrostatic field? Joules. What device is used to store electrical energy in an electrostatic field? Capacitor. What formula would determine the inductive reactance of a coil if frequency and coil inductance are known? XL equals 2FL. What is the term for the out-of-phase power associated with inductors and capacitors? Reactive power. What determines the strength of the magnetic field around a conductor? The amount of current. What will produce a magnetic field? A current flowing through a conductor. When induced currents produce expanding magnetic fields around conductors in a direction that opposes the original magnetic field, this is known as Lenz's law. The opposition to the creation of magnetic lines of force in a magnetic circuit is known as reluctance. What is meant by the term back EMF? A voltage that opposes the applied EMF. Permeability is defined as the ratio of magnetic flux density in a substance to the magnetizing force that produces it. What metal is usually employed as a sacrificial anode for corrosion control purposes? Zinc bar. What is the relative dielectric constant for air? 1. Which metal object may be least affected by galvanic corrosion when submerged in seawater? Stainless steel propeller shaft. Skin effect is the phenomenon where RF current flows in a thin layer of the conductor closer to the surface as frequency increases. Corrosion resulting from electric current flow between dissimilar metals is called galvanic corrosion. Which of these will be most useful for insulation at UHF frequencies? Mica. What formula would calculate the total inductance of inductors in series? LT equals L1 plus L2. Good conductors with minimum resistance have what type of electrons? Many free electrons. Which of the four groups of metals listed below are the best low-resistance conductors? Gold, silver, and copper. What is the purpose of a bypass capacitor? It removes alternating current by providing a low impedance path to ground. How would you calculate the total capacitance of three capacitors in parallel? CT equals C1 plus C2 plus C3. How might you reduce the inductance of an antenna coil? Reduce the number of turns. What are the two most commonly used specifications for a junction diode? Maximum forward current and PIV. What limits the maximum forward current in a junction diode? The junction temperature. MOSFETs are manufactured with this protective device built into their gate to protect the device from Zener Diode. What are the two basic types of junction field effect transistors? N-channel and P-channel. A common emitter amplifier has more voltage gain than a common collector. How does the input impedance of a field effect transistor compare with that of a bipolar transistor? An FET has high input impedance. A bipolar transistor has low input impedance. How does the input impedance of a field effect transistor compare with that of a bipolar transistor? An FET has high input impedance. A bipolar transistor has low input impedance. An AC ammeter indicates effective values of current. By what factor must the voltage of an AC circuit as indicated on the scale of an AC voltmeter be multiplied to obtain the peak voltage value? 1.414. What is the RMS voltage at a common household electrical power outlet? 117 VAC. What is the easiest voltage amplitude to measure by viewing a pure sine wave signal on an oscilloscope? Peak to peak. By what factor must the voltage measured in an AC circuit as indicated on the scale of an AC voltmeter be multiplied to obtain the average voltage value? 0.9. What is the peak voltage at a common household electrical outlet? 165.5 volts. What is a sine wave? A wave whose amplitude at any given instant can be represented by the projection of a point on a wheel rotating at a uniform speed. How many degrees are there in one complete sine wave cycle? 360 degrees. What type of wave is made up of sine waves of the fundamental frequency and all the odd harmonics? Square. What is the description of a square wave? A wave that abruptly changes back and forth between two voltage levels and stays at these levels for equal amounts of time. What type of wave is made up of sine waves at their fundamental frequency and all the harmonics? Sawtooth wave. What type of wave is characterized by rise time significantly faster than the fall time? Sawtooth wave. What is the term used to identify an AC voltage that would cause the same heating in a resistor as a corresponding value of DC voltage? Root mean square. What happens to reactive power in a circuit that has both inductors and capacitors? It alternates between magnetic and electric fields and is not dissipated. What happens to reactive power in a circuit that has both inductors and capacitors? It alternates between magnetic and electric fields and is not dissipated. Having the cross-sectional area of a conductor will double the resistance. Which of the following groups is correct for listing common materials in order of descending conductivity? Silver, copper, aluminum, iron, and lead. How do you compute true power in a circuit where AC voltage and current are out of phase? Multiply apparent power times the power factor. Assuming a power source to have a fixed value of internal resistance, maximum power will be transferred to the load when the load impedance equals the internal impedance of the source. What value of series resistor would be needed to obtain a full-scale deflection on a 50 microamp DC meter with an applied voltage of 200 volts DC? What value of series resistor would be needed to obtain a full-scale deflection on a 50 microamp DC meter with an applied voltage of 200 volts DC? 4 megohms. Which of the following Ohm's law formulas is incorrect? I equals R/E. If a current of 2 amperes flows through a 50 ohm resistor, what is the voltage across the resistor? 100 volts. If a 100 ohm resistor is connected across 200 volts, what is the current through the resistor? 2 amperes. If a current of 3 amperes flows through a resistor connected to 90 volts, what is the resistance? 30 ohms. A relay coil has 500 ohms resistance and operates on 125 megaamperes. What value of resistance should be connected in series with it to operate from 110 VDC? A relay coil has 500 ohms resistance and operates on 125 megaamperes. What value of resistance should be connected in series with it to operate from 110 VDC? 380 ohms. What is the peak-to-peak RF voltage on the 50 ohm output of a 100-watt transmitter? 200 volts. What is the maximum DC or RMS voltage that may be connected across a 20-watt 2000 ohm resistor? 200 volts. A 500 ohm 2-watt resistor and the 1500 ohm 1-watt resistor are connected in parallel. What is the maximum voltage that can be applied across the parallel circuit without exceeding wattage ratings? 31.6 volts. In Figure 3b1, what is the voltage drop across R1? 5 volts. In Figure 3b2, what is the voltage drop across R1? 9 volts. What is the maximum rated current carrying capacity of a resistor marked 2000 ohms, 200 watts? 0.316 amps. What is the most the actual transmit frequency could differ from a reading of 462,100,000 Hz on a frequency counter with a time-base accuracy of a plus or minus 0.1 ppm, 46.21 Hz. The second harmonic of a 380 kHz frequency is 760 kHz. What is the second harmonic of SSB frequency 4146 kHz? 8292 kHz. What is the most the actual transmitter frequency could differ from a reading of 156,520,000 Hz on a frequency counter with a time-base accuracy of a plus or minus 1.0 ppm, 156.52 Hz. What is the most the actual transmitter frequency could differ from a reading of 156,520,000 Hz on a frequency counter with a time-base accuracy of +/10 ppm, 1565.20 Hz. What is the most the actual transmitter frequency could differ from a reading of 462,100,000 Hz on a frequency counter with a time-base accuracy of a plus or minus 1.0 ppm, 462.1 Hz. At pi/3 radians, what is the amplitude of a sine wave having a peak value of 5 volts, plus 4.3 volts? At 150 degrees, what is the amplitude of a sine wave having a peak value of 5 volts, plus 2.5 volts? At 240 degrees, what is the amplitude of a sine wave having a peak value of 5 volts, minus 4.3 volts? What is the equivalent to the root mean square value of an AC voltage? The DC voltage causing the same heating in a given resistor as the RMS AC voltage of the same value. What is the equivalent to the root mean square value of an AC voltage? The DC voltage causing the same heating in a given resistor as the RMS AC voltage of the same value. What is the RMS value of a 340 volt peak-to-peak pure sine wave? 120 volts AC. Determine the phase relationship between the two signals shown in figure 3b3. B is lagging A by 90 degrees. What does the power factor equal in an RL circuit having a 60-degree phase angle between the voltage and the current? 0.5. If a resistance to which a constant voltage is applied is halved, what power dissipation will result? Double. 746 watts, corresponding to the lifting of 550 pounds at the rate of 1 foot per second, is the equivalent of how much horsepower? 1 horsepower. In a circuit where the AC voltage and current are out of phase, how can the true power be determined? By multiplying the apparent power times the power factor. What does the power factor equal in an RL circuit having a 45-degree phase angle between the voltage and the current? 0.707. What does the power factor equal in an RL circuit having a 30-degree phase angle between the voltage and the current? 0.866. What is the term for the time required for the capacitor in an RC circuit to be charged to 63.2% of the supply voltage? One-time constant. What is the meaning of the term time constant of an RC circuit? The time required to charge the capacitor in the circuit to 63.2% of the supply voltage. What is the term for the time required for the current in an RL circuit to build up to 63.2% of the maximum value? One-time constant. What is the meaning of the term time constant of an RL circuit? The time required for the current in the circuit to build up to 63.2% of the maximum value. After two time constants, the capacitor in an RC circuit is charged to what percentage of the supply voltage? 86.5%. After two time constants, the capacitor in an RC circuit is discharged to what percentage of the starting voltage? 13.5%. What is the time constant of a circuit having two 220 microfarad capacitors and two 1 megohm resistors all in parallel? 220 seconds. What is the time constant of a circuit having two 100 microfarad capacitors and two 470 kilo resistors all in series? 47 seconds. What is the time constant of a circuit having a 100 microfarad capacitor and a 470 kilo resistor in series? 47 seconds. What is the time constant of a circuit having a 220 microfarad capacitor and a 1 megohm resistor in parallel? 220 seconds. What is the time constant of a circuit having two 100 microfarad capacitors and two 470 kilo resistors all in parallel? 47 seconds. What is the time constant of a circuit having two 220 microfarad capacitors and two 1 megohm resistors all in series? 220 seconds. What is the impedance of a network composed of a 0.1 microhenry inductor in series with a 20 ohm resistor at 30 MHz? Specify your answer in rectangular coordinates. 20 plus J19. In rectangular coordinates, what is the impedance of a network composed of a 0.1 microhenry inductor in series with a 30 ohm resistor at 5 MHz? 30 plus J3. In rectangular coordinates, what is the impedance of a network composed of a 10 microhenry inductor in series with a 40 ohm resistor at 500 MHz? 40 plus J31400. In rectangular coordinates, what is the impedance of a network composed of a 1.0 millihenry inductor in series with a 200 ohm resistor at 30 kHz? B200 plus J188. In rectangular coordinates, what is the impedance of a network composed of a 0.01 microfarad capacitor in parallel with a 300 ohm resistor at 50 kHz? 159 J150. In rectangular coordinates, what is the impedance of a network composed of a 0.001 microfarad capacitor in series with a 400 ohm resistor at 500 kHz? 400 J318. What is the impedance of a network composed of a 100 picofarad capacitor in parallel with a 4000 ohm resistor at 500 kHz? Specify your answer in polar coordinates. 2490 ohms / minus 51.5 degrees. In polar coordinates, what is the impedance of a network composed of a 100 ohm reactance inductor in series with a 100 ohm resistor? 141 ohms / 45 degrees. In polar coordinates, what is the impedance of a network composed of a 400 ohm reactance capacitor in series with a 300 ohm resistor? 500 ohms / minus 53.1 degrees. In polar coordinates, what is the impedance of a network composed of a 300 ohm reactance capacitor, a 600 ohm reactance inductor, and a 400 ohm resistor, all connected in series? 500 ohms / 37 degrees. In polar coordinates, what is the impedance of a network comprised of a 400 ohm reactance inductor in parallel with a 300 ohm resistor? 240 ohms / 36.9 degrees. Using the polar coordinate system, what visual representation would you get of a voltage in a sine wave circuit? The plot shows the magnitude and phase angle. What is the magnitude of the impedance of a series AC circuit having a resistance of 6 ohms, an inductive reactance of 17 ohms, and zero capacitive reactance? 18 ohms. A 1 watt 10 volt Zener diode with the following characteristics: Min equals 5 mA, Rmax equals 95 mA, and Z equals 8 ohms is to be used as part of a voltage regulator in a 20V power supply. Approximately what size current limiting resistor would be used to set its bias to the midpoint of its operating range? 200 ohms. Given a power supply with a no-load voltage of 12 volts and a full load voltage of 10 volts, what is the percentage of voltage regulation? 0.2. What turns ratio does a transformer need in order to match a source impedance of 500 ohms to a load of 10 ohms? 7.1 to 1. Given a power supply with a full load voltage of 200 volts and a regulation of 25%, what is the no-load voltage? 250 volts. What is the conductance of a circuit if 6 amperes of current flows when 12 volts DC is applied? 0.50 Siemens. What happens to the conductivity of photoconductive material when light shines on it? It increases. What is the photoconductive effect? The increased conductivity of an illuminated semiconductor junction. What does the photoconductive effect in crystalline solids produce? A noticeable change in the resistance of the solid. What is the description of an optoisolator? An LED and a photosensitive device. What happens to the conductivity of a photosensitive semiconductor junction when it is illuminated? The junction resistance decreases. What is the description of an optocoupler? An LED and a photosensitive device. What factors determine the capacitance of a capacitor? Distance between the plates and the dielectric constant of the material between the plates. In Figure 3C4, if a small variable capacitor were installed in place of the dashed line, it would decrease parasitic oscillations. In Figure 3C4, which component is used to provide a signal ground? 2. In Figure 3C5, which capacitor is being used as a bypass capacitor? 3. In Figure 3C5, the 1 microfarad capacitor is connected to a potentiometer that is used to adjust tone. What is the purpose of a coupling capacitor? It blocks direct current and passes alternating current. A capacitor is sometimes placed in series with the primary of a power transformer to improve the power factor. A transformer used to step up its input voltage must have more turns of wire on its secondary than on its primary. A transformer primary of 2250 turns connected to 120 vac will develop what voltage across a 500 turn secondary? 26.7 volts. What is the ratio of the output frequency to the input frequency of a single-phase full-wave rectifier? 2:1. A power transformer has a single primary winding and 3 secondary windings producing 5.0 volts, 12.6 volts. A power transformer has a single primary winding and 3 secondary windings producing 5.0 volts, 12.6 volts, and 150 volts. Assuming similar wire sizes, which of the 3 secondary windings will have the highest measured DC resistance? The 150 volt winding. A power transformer has a primary winding of 200 turns of number 24 wire and a secondary winding consisting of 500 turns of the same size wire. When 20 volts are applied to the primary winding, the expected secondary voltage will be 50 volts. In a linear electronic voltage regulator, the conduction of a control element is varied in direct proportion to the line voltage or load current. In a linear electronic voltage regulator, the conduction of a control element is varied in direct proportion to the line voltage or load current. A switching electronic voltage regulator switches the control device on or off with the duty cycle proportional to the line or load conditions. What device is usually used as a stable reference voltage in a linear voltage regulator? Zener Diode. In a regulated power supply, what type of component will most likely be used to establish a reference voltage? Zener Diode. A 3-terminal regulator contains a voltage reference, error amplifier, sensing resistors and transistors, and a pass element. What is the range of voltage ratings available in Zener diodes? 2.4 volts to 200 volts and above. How might two similar SCRs be connected to safely distribute the power load of a circuit? In parallel reverse polarity. What are the 3 terminals of an SCR? Anode, cathode, and gate. What are the 3 terminals of an SCR? Anode, cathode, and gate. Which of the following devices access 2 SCRs connected back-to-back but facing in opposite directions and sharing a common gate? Triac. What is the transistor called that is fabricated as 2 complementary SCRs in parallel with a common gate terminal? Triac. What are the 3 terminals of a triac? Gate, anode 1 and anode 2. What circuit might contain a SCR? A light dimming circuit. What is one common use for PIN diodes? RF switch. What is a common use of a hot carrier diode? VHF and UHF mixers and detectors. Structurally, what are the 2 main categories of semiconductor diodes? Junction and point contact. What special type of diode is capable of both amplification and oscillation? Tunnel diodes. What type of semiconductor diode varies its internal capacitance as the voltage applied to its terminals varies? The reactor diode. What is the principal characteristic of a tunnel diode? Negative resistance region. What is the meaning of the term alpha with regard to bipolar transistors? The change of collector current with respect to emitter current. What is the meaning of the term alpha with regard to bipolar transistors? The change of collector current with respect to emitter current. What are the 3 terminals of a bipolar transistor? Base, collector, and emitter. What is the meaning of the term beta with regard to bipolar transistors? The change of collector current with respect to base current. What are the elements of a unit junction transistor? Base 1, base 2, and emitter. The beta cutoff frequency of a bipolar transistor is the frequency at which Emitter current gain has decreased to 0.707 of maximum. What does it mean for a transistor to be fully saturated? The collector current is at its maximum value. A common base amplifier has more voltage gain than common emitter or common collector. What does it mean for a transistor to be cut off? There is no current between emitter and collector. An emitter follower amplifier has more current gain than common emitter or common base. What conditions exist when a transistor is operating in saturation? The base emitter junction and collector base junction are both forward biased. For current to flow in an NPN silicon transistor's emitter-collector junction, the base must be at least 0.7 volts positive with respect to the emitter. When an NPN transistor is operating as a Class A amplifier, the base emitter junction is forward biased and the collector base junction is reverse biased. What type of bias is required for an LED to produce luminescence? Forward bias. What determines the visible color radiated by an LED junction? The materials used to construct the device. What is the approximate operating current of a light-emitting diode? 20 mA. What would be the maximum current to safely illuminate a LED? 20 mA. An LED facing a photodiode in a light-tight enclosure is commonly known as an optoisolator. What circuit component must be connected in series to protect an LED? Series resistor. What describes a diode junction that is forward biased? It is a low impedance. Why are special precautions necessary in handling FET and CMOS devices? They are susceptible to damage from static charges. What do the initials CMOS stand for? Complementary metal oxide semiconductor. Complementary metal oxide semiconductor. What is the piezoelectric effect? Mechanical vibration of a crystal by the application of a voltage. Mechanical vibration of a crystal by the application of a voltage. An electrical relay is a remotely controlled switching device. In which oscillator circuit would you find a quartz crystal? Pierce. What is the approximate magnitude of the impedance of a parallel RLC circuit at resonance? Approximately equal to the circuit resistance. What is the approximate magnitude of the impedance of a parallel RLC circuit at resonance? Approximately equal to the circuit resistance. What is the approximate magnitude of the impedance of a series RLC circuit at resonance? Approximately equal to the circuit resistance. Approximately equal to the circuit resistance. How could voltage be greater across reactances in series than the applied voltage? Resonance. What is the characteristic of the current flow in a series RLC circuit at resonance? Maximum. What is the characteristic of the current flow within the parallel element in a parallel RLC circuit at resonance? Maximum. What is the relationship between current through resonance? What is the relationship between current through a resonant circuit and the voltage across the circuit? The voltage and current are in phase. What is the main advantage of using an op-amp audio filter over a passive LC audio filter? Op-amps exhibit gain rather than insertion loss. What are the characteristics of an inverting operational amplifier circuit? It has input and output signals 180 degrees out of phase. Gain of a closed-loop op-amp circuit is determined by the op-amp's external feedback network. Where is the external feedback network connected to control the gain of a closed-loop op-amp circuit? From output to the inverting input. Which of the following op-amp circuits is operated open-loop? Comparator. In the op-amp oscillator circuit shown in Figure 3d6, what would be the most noticeable effect if the capacitance of C were suddenly doubled? Frequency would be lower. What frequency synthesizer circuit uses a phase comparator, lookup table, digital to analog converter, and a low-pass anti-alias filter? A direct digital synthesizer. A circuit that compares the output of a voltage-controlled oscillator to a frequency standard and produces an error voltage that is then used to adjust the capacitance of a varactor diode used to control frequency in that same VCO is called what? Phase-locked loop. A circuit that compares the output of a voltage-controlled oscillator to a frequency standard and produces an error voltage that is then used to adjust the capacitance of a varactor diode used to control frequency in that same VCO is called what? Phase-locked loop. RF input to a mixer is 200 MHz and the local oscillator frequency is 150 MHz. What output would you expect to see at the IF output prior to any filtering? 5100, 5200 and 350 MHz. What spectral impurity components might be generated by a phase-locked loop synthesizer? Broadband noise. In a direct digital synthesizer, what are the unwanted components on its output? Spurs at discrete frequencies. What is the definition of a phase-locked loop circuit? A servo loop consisting of a phase detector, a low-pass filter and voltage-controlled oscillator. What is the definition of a phase-locked loop circuit? A servo loop consisting of a phase detector, a low-pass filter and voltage-controlled oscillator. A servo loop consisting of a phase detector, a low-pass filter and voltage-controlled oscillator. Given the combined DC input voltages, what would the output voltage be in the circuit shown in Figure 3D7? Minus 5.5 V. Which lamps would be lit in the circuit shown in Figure 3D8? 2, 3, 4, 7 and 8. What will occur if an amplifier input signal coupling capacitor fails open? No amplification will occur with DC within the circuit measuring normal. In Figure 3D9, determine if there is a problem with this regulated power supply and identify the problem. There is no problem with the circuit. In Figure 3D10 with a square wave input, what would be the output? 3. With a pure AC signal input to the circuit shown in Figure 3D11, what output waveform would you expect to see on an oscilloscope display? 2. What is the voltage range considered to be valid logic low input in a TTL device operating at 5 volts? 0 to 0.8 volts. What is the voltage range considered to be a valid logic high input in a TTL device operating at 5.0 volts? 2.0 to 5.5 volts. What is the common power supply voltage for TTL series integrated circuits? 5 volts. TTL inputs left open develop what logic state? A high logic state. Which of the following instruments would be best for checking a TTL logic circuit? Logic probe. What do the initials TTL stand for? Transistor logic. What is a characteristic of an AND gate? Produces a logic 1 at its output only if all inputs are logic 1. What is a characteristic of an AND gate? Produces a logic 0 at its output only when all inputs are logic 1. What is a characteristic of an OR gate? Produces a logic 1 at its output if any input is logic 1. What is a characteristic of an NOR gate? Produces a logic 0 at its output if any or all inputs are logic 1. What is a characteristic of a NOT gate? Produces a logic 0 at its output when the input is logic 1 and vice versa. Which of the following logic gates will provide an active high out when both inputs are active high? AND. In a negative logic circuit, what level is used to represent a logic 0? High level. For the logic input levels shown in Figure 3.12, what are the logic levels of test points A, B and C in this circuit? A is low, B is high and C is high. A is low, B is high and C is high. For the logic input levels given in Figure 3e13, what are the logic levels of test points A, B and C in this circuit? A is high, B is high and C is high. In a positive logic circuit, what level is used to represent a logic 1? High level. Given the input levels shown in Figure 314 and assuming positive logic devices, what would the output be? A is low, B is high and C is high. A is low, B is high and C is high. What is a truth table? A list of input combinations and their corresponding outputs that characterizes a digital device's function. A list of input combinations and their corresponding outputs that characterizes a digital device's function. A flip-flop circuit is a binary logic element with how many stable states? 2. What is a flip-flop circuit? A binary sequential logic element with blank stable states. 2. How many flip-flops are required to divide a signal frequency by 4? 2. How many bits of information can be stored in a single flip-flop circuit? 1. How many RS flip-flops would be required to construct an 8-bit storage register? 8. An RS flip-flop is capable of doing all of the following except operate in toggle mode with RS inputs held constant and CLK initiated. The frequency of an AC signal can be divided electronically by what type of digital circuit? Bistable multivibrator. The frequency of an AC signal can be divided electronically by what type of digital circuit? Bistable multivibrator. What is an astable multivibrator? A circuit that alternates between two unstable states. What is a monostable multivibrator? A circuit that can be switched momentarily to the opposite binary state and then returns after a set time to its original state. What is a bistable multivibrator circuit commonly named? Flip-flop. What is a bistable multivibrator circuit? Flip-flop. What waveform would appear on the voltage outputs at the collectors of an astable multivibrator common emitter stage? Square wave. What is the name of the semiconductor memory IC whose digital data can be written or read and whose memory word address can be accessed randomly? RAM, random access memory. What is the name of the semiconductor IC that has a fixed pattern of digital data stored in its memory matrix? ROM, read-only memory. What does the term I/O mean within a microprocessor system? Input-output. What is the name for a microprocessor's sequence of commands and instructions? Program. How many individual memory cells would be contained in a memory IC that has 4 data bus input-output pins and 4 address pins for connection to the address bus? 64. What is the name of the random accessed semiconductor memory IC that must be refreshed periodically to maintain reliable data storage in its memory matrix? DRAM, dynamic random access memory. In a microprocessor-controlled two-way radio, a watchdog timer verifies that the microprocessor is executing the program. In a microprocessor-controlled two-way radio, a watchdog timer verifies that the microprocessor is executing the program. What does the term DAC refer to in a microprocessor circuit? Digital to analog converter. Which of the following is not part of a MCU processor? Voltage regulator. What portion of a microprocessor circuit is the pulse generator? Clock. In a microprocessor, what is the meaning of the term ALU? Arithmetical logic unit. What circuit interconnects the microprocessor with the memory and input-output system? Data bus line. What is the purpose of a prescaler circuit? Divides an HF signal so that a low-frequency counter can display the operating frequency. Divides an HF signal so that a low-frequency counter can display the operating frequency. What does the term BCD mean? Binary coded decimal. What is the function of a decade counter digital IC? Produce 1 output pulse for every 10 input pulses. Produce 1 output pulse for every 10 input pulses. What integrated circuit device converts an analog signal to a digital signal? ADC. What integrated circuit device converts digital signals to analog signals? DAC. In binary numbers, how would you note the quantity 2? 10. What is the limiting condition for sensitivity in a communications receiver? The noise floor of the receiver. What is the definition of the term receiver desensitizing? A reduction in receiver sensitivity because of a strong signal on a nearby frequency. What is the definition of the term receiver desensitizing? A reduction in receiver sensitivity because of a strong signal on a nearby frequency. What is the term used to refer to a reduction in receiver sensitivity caused by unwanted high-level adjacent channel signals? Desensitizing. What is meant by the term noise figure of a communications receiver? The level of noise generated in the front end and succeeding stages of a receiver. What is meant by the term noise figure of a communications receiver? The level of noise generated in the front end and succeeding stages of a receiver. Which stage of a receiver primarily establishes its noise figure? The RF stage. What is the term for the ratio between the largest tolerable receiver input signal and the minimum discernible signal? Dynamic range. How can selectivity be achieved in the front-end circuitry of a communications receiver? By using a preselector. What is the primary purpose of an RF amplifier in a receiver? To improve the receiver's noise figure. How much gain should be used in the RF amplifier stage of a receiver? Sufficient gain to allow weak signals to overcome noise generated in the first mixer stage. Too much gain in a VHF receiver front end could result in this. Susceptibility of intermodulation interference from nearby transmitters. What is the advantage of a Quizlet preamplifier in a modern VHF radio receiver? High gain and low noise floor. In what stage of a VHF receiver would a low noise amplifier be most advantageous? Front-end RF stage. Why is the Colpitts oscillator circuit commonly used in a VFO? It is stable. What is the oscillator stage called in a frequency synthesizer? VCO. What are 3 major oscillator circuits found in radio equipment? Colpitts, Hartley, and Pierce. Which type of oscillator circuit is commonly used in a VFO? Colpitts. What condition must exist for a circuit to oscillate? It must have sufficient positive feedback. In Figure 3F15, which block diagram symbol is used to represent a local oscillator? 2. What is the image frequency if the normal channel is 151.000 MHz, the IF is operating at 11.000 MHz, and the LO is at 140.000 MHz, 129.000 MHz? What is the mixing process in a radio receiver? The combination of 2 signals to produce sum and difference frequencies. The combination of 2 signals to produce sum and difference frequencies. In what radio stage is the image frequency normally rejected? RF. What are the principal frequencies that appear at the output of a mixer circuit? The original frequencies and the sum and difference frequencies. What are the principal frequencies that appear at the output of a mixer circuit? The original frequencies and the sum and difference frequencies. If a receiver mixes a 13.8 MHz VFO with a 14.255 MHz received signal to produce a 455 kHz intermediate frequency signal, what type of interference will a 13.345 MHz signal produce in the receiver? An image response. What might occur in a receiver if excessive amounts of signal energy overdrive the mixer circuit? Spurious mixer products are generated. What degree of selectivity is desirable in the IF circuitry of a wideband FM phone receiver? 15 kHz. Which one of these filters can be used in micro-miniature electronic circuits? Receiver SAWIF filter. A receiver selectivity of 2.4 kHz in the IF circuitry is optimum for what type of signals? SSB voice. A receiver selectivity of 10 kHz in the IF circuitry is optimum for what type of signals? Double sideband AM. What is an undesirable effect of using too wide a filter bandwidth in the IF section of a receiver? Undesired signals will reach the audio stage. How should the filter bandwidth of a receiver IF section compare with the bandwidth of a received signal? Slightly greater than the received signal bandwidth. How should the filter bandwidth of a receiver IF section compare with the bandwidth of a received signal? Slightly greater than the received signal bandwidth. What is the primary purpose of the final IF amplifier stage in a receiver? Gain. What factors should be considered when selecting an intermediate frequency? Image rejection and selectivity. What is the primary purpose of the first IF amplifier stage in a receiver? Selectivity. What parameter must be selected when designing an audio filter using an op-amp? Bandpass characteristics. What are the distinguishing features of a Chebyshev filter? It allows ripple in the passband. When would it be more desirable to use an M-derived filter over a constant K filter? When you need more attenuation at a certain frequency that is too close to the cutoff frequency for a constant K filter. A good crystal bandpass filter for a single sideband phone would be 2.1 kHz. Which statement is true regarding the filter output characteristics shown in Figure 3F16? A is a low-pass curve and D is a band-stop curve. What are the three general groupings of filters? High pass, low pass and band pass. What is an M-derived filter? A filter that uses a trap to attenuate undesired frequencies too near cutoff for a constant K filter. What is an M-derived filter? A filter that uses a trap to attenuate undesired frequencies too near cutoff for a constant K filter. What is an advantage of a constant K filter? It is high attenuation of signals at frequencies far removed from the pass band. It is high attenuation of signals at frequencies far removed from the pass band. What are the distinguishing features of a Butterworth filter? It is a maximally flat response over its passband. What is a product detector? It uses a mixing process with a locally generated carrier. Which circuit is used to detect FM phone signals? B. Frequency discriminator. What is the process of detection in a radiodiode detector circuit? Rectification and filtering of RF. Which circuit is used to detect FM phone signals? B. Frequency discriminator. What is the process of detection in a radiodiode detector circuit? Rectification and filtering of RF. What is a frequency discriminator in a radio receiver? A circuit for detecting FM signals. In a CTCSS-controlled FM receiver, the CTCSS tone is filtered out after the discriminator but before the audio section. What is the definition of detection in a radio receiver? The recovery of intelligence from the modulated RF signal. What is the digital signal processing term for noise subtraction circuitry? Adaptive filtering and autocorrelation. What is the purpose of de-emphasis in the receiver audio stage? When coupled with the transmitter pre-emphasis, flat audio and noise reduction is received. What makes a digital coded squelch work? Digital codes. What causes a squelch circuit to function? Presence of noise. What makes a CTCSS squelch work? Tones. What radio circuit samples analog signals, records and processes them as numbers, then converts them back to analog signals? The digital signal processing circuit. Where would you normally find the low-pass filter in a radio receiver? A and C, but not B. How can ferrite beads be used to suppress ignition noise? Install them. Install them in the primary and secondary ignition leads. What is the term used to refer to the condition where the signals from a very strong station are superimposed on other signals being received? Cross-Modulation Interference. What is the term used to refer to the condition where the signals from a very strong station are superimposed on other signals being received? Cross-Modulation Interference. What is cross-modulation interference? Modulation from an unwanted signal heard in addition to the desired signal. In Figure 3F15, at what point in the circuit could a DC voltmeter be used to monitor signal strength? 4. Pulse-type interference to automobile radio receivers that appears related to the speed of the engine can often be reduced by installing resistances in series with spark plug wires. What class of amplifier is distinguished by the presence of output throughout the entire signal cycle and the input never goes into the cutoff region? Class A. What is the distinguishing feature of a Class A amplifier? Output for the entire 360 degrees of the signal cycle. Which class of amplifier has the highest linearity and least distortion? Class A. Which class of amplifier provides the highest efficiency? Class C. What class of amplifier is distinguished by the bias being set well beyond cutoff? Class C. Which class of amplifier has an operating angle of more than 180 degrees but less than 360 degrees when driven by a sine wave signal? Class AB. The Class B amplifier output is present for what portion of the input cycle? 180 degrees. What input amplitude parameter is most valuable in evaluating the signal handling capability of a Class A amplifier? Peak voltage. The Class C amplifier output is present for what portion of the input cycle? Less than 180 degrees. What is the approximate DC input power to a Class AB RF power amplifier stage in an unmodulated carrier transmitter when the PEP output power is 500 watts? 1000 watts. The Class AB amplifier output is present for what portion of the input cycle? More than 180 but less than 360 degrees. What class of amplifier is characterized by conduction for 180 degrees of the input wave? Class B. What is the modulation index in an phantom phone signal having a maximum frequency deviation of 3000 Hz on either side of the carrier frequency when the modulating frequency is 1000 Hz? 3. What is the modulation index of a phantom phone transmitter producing a maximum carrier deviation of 6 kHz when modulated with a 2 kHz modulating frequency? 3. What is the total bandwidth of a phantom phone transmission having a 5 kHz deviation and a 3 kHz modulating frequency? 16 kHz. How does the modulation index of a phase-modulated emission vary with RF carrier frequency? It does not depend on the RF carrier frequency. How can a single sideband phone signal be generated? By using a balanced modulator followed by a filter. What is a balanced modulator? A modulator that produces a double sideband suppressed carrier signal. What is an L network? A network consisting of an inductor and a capacitor. What is a pi network? A network consisting of one inductor and two capacitors or two inductors and one capacitor. What is the resonant frequency in an electrical circuit? The frequency at which capacitive reactance equals inductive reactance. Which three network types are commonly used to match an amplifying device to a transmission line? L network, pi network and pi L network. What is a pi-L network? A network consisting of 2 inductors and 2 capacitors. Which network provides the greatest harmonic suppression? Pi-L network. What will occur when a nonlinear amplifier is used with a single sideband phone transmitter? Distortion. To produce a single sideband suppressed carrier transmission, it is necessary to blank the carrier and to blank the unwanted sideband. Cancel filter. To produce a single sideband suppressed carrier transmission, it is necessary to blank the carrier and to blank the unwanted sideband. Cancel filter. In a single sideband phone signal, what determines the PEP to average power ratio? The speech characteristics. What is the approximate ratio of peak envelope power to average power during normal voice modulation peak in a single sideband phone signal? 2.5 to 1. What is the output peak envelope power from a transmitter as measured on an oscilloscope showing 200 volts peak to peak across a 50 ohm load resistor? 100 watts. What would be the voltage across a 50 ohm dummy load dissipating 1200 watts? 245 volts. How can intermodulation interference between 2 transmitters in close proximity often be reduced or eliminated? By installing a terminated circulator or ferrite isolator in the feed line to the transmitter and duplexer. How can intermodulation interference between 2 transmitters in close proximity often be reduced or eliminated? By installing a terminated circulator or ferrite isolator in the feed line to the transmitter and duplexer. How can parasitic oscillations be eliminated in a power amplifier? By neutralization. What is the name of the condition that occurs when the signals of 2 transmitters in close proximity mix together in one or both of their final amplifiers and unwanted signals at the sum and difference frequencies of the original transmissions are generated? Intermodulation interference. What is the name of the condition that occurs when the signals of 2 transmitters in close proximity mix together in one or both of their final amplifiers and unwanted signals at the sum and difference frequencies of the original transmissions are generated? Intermodulation interference. What term describes a wide bandwidth communications system in which the RF carrier varies according to some predetermined sequence? Spread spectrum communication. How can even-order harmonics be reduced or prevented in transmitter amplifier design? By using a push-pull amplifier. What is the modulation type that can be a frequency hopping of one carrier or multiple simultaneous carriers? Spread spectrum. The deviation ratio is the maximum carrier frequency deviation to the highest audio modulating frequency. The deviation ratio is the maximum carrier frequency deviation to the highest audio modulating frequency. What is the deviation ratio for an fathom phone signal having a maximum frequency deviation of plus or minus 5 kHz and accepting a maximum modulation rate of 3 kHz? 1. What is the deviation ratio for an fathom phone signal having a maximum frequency deviation of plus or minus 5 kHz and accepting a maximum modulation rate of 3 kHz? 1.66. What is the deviation ratio of an fathom phone signal having a maximum frequency swing of plus or minus 7.5 kHz and accepting a maximum modulation rate of 3.5 kHz? 2.14. How can an fathom phone signal be produced in a transmitter? By feeding the audio directly to the oscillator. What is meant by the term modulation index? The ratio between the deviation of a frequency modulated signal and the modulating frequency. In an fathom phone signal, what is the term for the maximum deviation from the carrier frequency divided by the maximum audio modulating frequency? Deviation ratio. In an fathom phone signal, what is the term for the maximum deviation from the carrier frequency divided by the maximum audio modulating frequency? Deviation ratio. In Figure 3/17, the block labeled 4 would indicate that this schematic is most likely an SSB radio transmitter. SSB radio transmitter. In Figure 3/17, which block diagram symbol represents where audio intelligence is inserted. 2. What kind of input signal could be used to test the amplitude linearity of a single sideband phone transmitter while viewing the output on an oscilloscope? A two-tone audio frequency sine wave. What kind of input signal could be used to test the amplitude linearity of a single sideband phone transmitter while viewing the output on an oscilloscope? A two-tone audio frequency sine wave.